All right, so we're going to go ahead and I guess jump into this. Dr. Van Sickle's maybe seen part of this before, so we'll kind of aim this at the students here in the classroom. So it's kind of an overview of what we do here at ATSU as far as supporting academic groups, and also on the research side too, and how we can help people and solve problems and produce cool things for people. So we talked a little bit about this in the last one, where our 3D object is a file that contains X, Y, and Z locations for all different points, and then you can see this in everyday use from printing things to actually the movie type stuff, where you, like you showed, you had the little puppet pieces, but then also any kind of CGI dinosaur movie or whatever. It's all made from a 3D object. And some of the stuff we use here at ATSU, we've kind of tended towards the free, I guess, at this point, just kind of dipping our toes into it. So Mix Mixture, GrabCAD are kind of easy ones. Fusion 360 is a little harder. Blender is a very good program. Takes a lot of work and a big learning curve to it. And then SolidWorks and some of the other ones that are pretty expensive. So we've kind of stuck with some of the easier ones to use at this point. And different programs have different uses as well. This is a mock-up of a conference room that we're building, third floor of our dental thing. So I did a little mock-up of it to kind of show people what it would look like in this conference room. So that's SketchUp, and it's more architectural. We have researchers and faculty who are interested in shapes of molecules, and like Dr. Cox, I think we printed out some molecule stuff for him, and so getting a 3D object out of a physical object or creating it, there's different ways to do that. One of the ways to do this is scanning. So we've got a couple of these next engine laser scanners here on this campus, and also in Mesa, Arizona. I think Dr. Young has one as well. Yeah. And it takes measurements with the laser, and you put the object on there and it rotates it around, and it really works for the smaller type objects. There's different ways to do this too with photogrammetry, where you can take pictures or even a video and get pieces for software to kind of rebuild a 3D object in it. And also with scanners, Dr. Van Sickle now has it's Architect Space Spider, is that what it's called? So it's a little
got it last week.
handheld scanner. It would presumably we could do a lot bigger things with than the little next engine scanner.
Up to about the size of a microwave is what I was told. After that, it's a little tricky.
Okay. So there's different tools out there for getting real world objects into a 3D file. And here's another example of one thing we did was take a plaster cast from the museum here at ATSU University, and it's AT Still's hand from a live cast we did 100 years ago. And Jason Haxton, the museum director here, is pretty protective of this and doesn't really like to take it on the road. So we made a scan of it, and then we were able to print that out, and then we can take it around. There's a model of it over there printed out with wood filament. And this is, if you've been downtown Kirksville, you've seen the AT Still statue. We did a photogrammetry of that, to where took a bunch of pictures with a DSLR camera from down low and up high, so I could get on a ladder and kind of all the way around, and put that into the result through a photogrammetry software, and ended up making a little AT Still statue now that I have in my office. And I think Debbie has some of them too.
We have one too, yeah.
And it took a little bit of work to fix the model from the photogrammetry thing and to fill in the holes and imperfections, and it was pretty mushy in the face to start with. And I went in through some different things and created more detail in it with modeling, and to where it looks reasonable now.
This is actually something that the library created. We were asked to take a CAT scan and recreate this heart. And Jay worked on this for several months, getting it out of the CAT scan and filling in the holes. And then we printed it in the hard ABS material and then also the soft PLA material. They're writing the doctor that's requested it is actually writing a research paper. And so it was one of our first attempts taking a CAT scan and converting it into an STL file.
So you have like a Osirix is the program you're using for that? So
Yes.
it takes the scan, you can isolate out that part and then from that create your model.
Yeah.
And also I talked a little bit about this too. Whenever you're making a model out of a real life object, sometimes it ends up with places that don't get filled in. You end up with holes in your model. You end up with places that the scanner or your photogrammetry can't reach. So if you're going to make a 3D object in the real world out of that, you have to make sure that you close up the holes. And sometimes you can do that within a program, and some of them have automatic hole filling capability to make it manifold or watertight. Sometimes it'll just make a flat surface across there, and you might want something curved, so you have to kind of use that. You have to use a little bit of judgment with that too, as to how that works. And so our group here, the academic technology group, we're generally working with researchers, we're working with instructors, trying to figure out, how to solve a problem, how to make something that will fix an issue they're having, or to help them do something cheaper or better or faster. And in something in real life and building pieces. And like I said, we've got little pieces in our 3D printing area where we said, oh, it'd be kind of cool to have a little tool like that. So we designed something and print it. And so it's really helpful to have that. And what we've done, this is a image of a dental plate that Dr. Masawi was wanting us to build for the dental lab here. So we met with them, we did some measurements, we kind of drew it out and kind of had some ideas of what we wanted. It had to fit into a receiver, so we had to make sure it was close to be, and then we built some models. We did some prototypes with that, made some test prints to see how it fit. We made adjustments to that because it wasn't quite right the first time, and we reprinted and did that several times in different iterations and different little tweaks to it to where we could get it to work. So it's kind of a process for whenever you're doing a build like that. But we ended up, getting some decent plates for him, and we had Debbie print some and we printed some, so we kind of made it work out. And another real world thing that we did here was that there's a confocal microscope that a lot of the researchers use, and we needed a special piece to hold a slide for it that they didn't have. So we worked with June Suk and had this built, and she kind of gave us an idea of what she needed, and we made it into a real life object, which is helpful to her.
This is actually something that we all work together on also for the research department, the Still Research Institute. The models on your right are brass, and they were looking for something that was a little more detailed and less expensive to reproduce, because that's about $2,000 to make. And so we worked with Dr. Dagenhart and his team and Dean and Jamie, and recreated them into STL files and printed them. The first set on the top is actually solid, and we printed it on a base, and then they decided that they would like something with a little more movement. So we built the base individually with each vertebrae so it could roll through on a rod, so it was more manipulative for the students to use. So we actually saved the department about $20,000 by printing this in-house. And if one breaks, all they have to do is give me a call and we print a new one. So a good way to save money for the departments. We do print free for the students, but we do ask departments when they have projects like this to cover the cost of the material.
And like we kind of discussed earlier, if you have something that's broken or lost, or you want to create it, this is a simple thing we did where we were missing a foot on a stool and just replace that. And it's simple and easy, but it makes it very useful. And so it's kind of our side of it is kind of we're working with professors and researchers and coming up with, fixes for problems. And we're kind of getting a little bit into the library side of it is more the working with students, coming up with things that will help the students.
Yeah, the library side, again, the library prints these items free for the students. We have hundreds and hundreds of files, anatomy files. They can come in and ask for a heart or skull, foot, whatever. Or they can find something online that they need as long as it fits the educational profile, depending on if you're a dental student or a medical student. A couple of the other things that we've done is actually worked on some projects that we thought would be helpful for the students. One of those things was these are our three printers that we have in the library here on this campus. And then the Arizona campus has a Mojo printer. So we can print anything up to a 10 by 10 on the F-170, and the Mojo prints a 5 by 5, and the Affinia prints a 10 by 8. So it gives us a lot of flexibility. We can print parts and glue them together, things like that. So we can make much bigger models, as you can see with our, what was that?
Monitor lizard.
Thank you, monitor lizard, the lizard. So we printed that all on our Mojo, which is a 5 by 5, and then we glued all the pieces together. Again, it's free for the students. We do ask the departments to, if they're having a special project, to cover just the cost of the material. They're not paying my time or the machine's time or anything like that. So they're still saving a huge amount of money. One of the things,
yeah, kind of what we were talking about just then was the free to the students.
Yeah.
And if we do need to print something that's bigger, or we need multicolor, where we don't have the capability to do the multicolor or multi-material at once, we can have that sent off to someplace that will do that. So we can make things work.
These are some of the sites that we suggest students to look at when they're looking for parts. If it's something we don't have, they're all free. They're great sites. The one thing we do ask is that if you're interested in something, if you'll send me the link or Dean the link, we'll take a look and make sure the file is good. Sometimes those CAT scans that are done aren't always cleaned up before they're posted, which means you get prints and parts instead of the one piece. So, they're all free. Feel free to look at them, pick something out you like, and then let us know, and we'll make sure that it's okay.
Yeah, a lot of times we can repair some of that stuff too, because we've gotten models from, especially the NIH site. There's a lot of pretty sketchy stuff that goes up there, and sometimes we're able to take that and fill in some of the holes and make it to where it is printable.
It takes a long time to clean up a file.
It does take a long time to clean up a file.
So these are a couple of things that we've printed in the library. As you can see, the different array of lizard and reptile heads. This is a research project that Dr. Young is working on. This was all printed on the small Mojo machine. So these are like 5 by 5 pieces or smaller that we've glued together and painted. The cool thing is we wanted to show too that you can actually paint these. So you spray them with a little bit of primer. You can paint them however you want. If you want to mark them up for study, if you just want to make them psychedelic because they looks cool, you can do whatever you want with them. On the other side, the eyeballs were actually created by some students for a 3D contest a few years back. And they're wired up with fishing line, so you can move the strings to represent how the eye moves. They're actually looking at doing a 2.0 version of this with possibly some electronics. So I'm looking forward to working with them on that. This is a project that 2 students and I and Jamie and Academic Technologies have been working on since 2017. We just sent our patent application in last week, so we're really excited about that. We printed everything in-house. I made these with the students in my kitchen at home. We went down to Home Depot and you know, went up and down the aisles trying to think about what we needed and thinking outside the box on how to build them. The great thing is the ballistics gel that's surrounding them is medical grade. So it works just like if you were ultrasounding a patient. You can use it to practice giving injections. That's what they're created for. So we have a cervical, lumbar, and a pelvic model. And so they've been really handy. The students have taken them over. They really like them. We've been asked to make more. So we're really excited about that project. The library does have a technology room on this campus and also on the Arizona campus. We each have different softwares and things that you can use. This is some of the things here. The library page does have a 3D lab guide to it that has tutorials and links to other software programs that you can look at. We have books in the library that you can check out. We have several people you can ask for help. We started a 3D club this year, so we're encouraging anyone that's interested to join that. If you know nothing about 3D printers, or if you know everything about 3D printers, we're encouraging people to join that. And then the Arizona, again, the Arizona also has a technology room filled with the software and the next-gen scanner and things like that.
So in general, we're here to support the academics and the research and the students as well, and to help kind of push us along. We're kind of, we've had a Mojo printer for, we're talking with Aaron, with that, so it's probably 4, 5, 6 years.
We got ours in 2015.
Okay. And
so, yeah, the library did. I don't know how long you've had yours, but
I think we had ours a little bit longer.
Yeah.
But yeah, we've been doing this for a while. We're not really in like an engineering type school. We have students that are coming in, but we do have students that come to us with a background in this from their undergrad, so that's helpful. So we're kind of building on what we have. We're looking forward to new tools as they come out, and new things that Stratasys can send to us to play with. So we're looking forward to growing our program and working more with students and helping our faculty and staff.
Yeah, I mean, if there's a tool or an idea that someone's interested in, something you think the students might be interested in using as a learning tool, we're always happy to listen and see if we can figure out. That's why the ballistics gel project started the way it was, is it was designed to be a learning tool for the students. So we're willing to try anything. Any questions?
All right.
Okay.
Very good. Well, I guess we take a short break.
Yep.
Thank you, guys.
Yep.